Okay, guys, so this is E-2, part 2. So you will need a calculator for this. So please make sure you have one with you. It'll be for the last problem. So directions, you are given the graph of f. State whether f prime of a is equal to 0, or it is undefined, or it is positive, or it is negative. Okay, so let's go through and do all of these. Alrighty, so how are we gonna, well, first we have to identify the point on the graph at A. So here's A, go up to the graph. Okay, there's a line there. Okay, so what we're looking for is M tan. So in this case, f prime of A, which is equal to M tan, is equal to 0. Okay, and then, okay, so then this next one, go to A, go up to the graph. All right, in this case, it is positive. And then you, again, there's the tangent line. All right, and then for this one, so this is a sharp corner or a cusp, and try to draw a tangent line, and you're not going to be able to. It's very confusing. So, like, if you ignore, like, this half of the graph, all right, and then, so it looks like the tangent line should be, like this and, getting closer to that. But then if on the other side, try to draw it's not happening. And actually, the closer you get to this point, the tangent line is like approaching like almost a vertical tangent. So the slope is undefined. You cannot define the slope at that point, nor you can't even draw a tangent line. So you need like smoothness to even be able to draw a tangent line. F prime of A is undefined. Okay. All right, guys. So now page 9. So this is just a little review here. So recall the candidates test for absolute extrema. These only occur on an interval. Absolute extrema are not local extrema. Local extrema can be absolute, but an absolute extrema might not be a local. It might happen at an endpoint. So these always occur on an interval. And to find them, first find the critical numbers. I should say of f. Find the critical numbers of f. And then cross out any critical numbers that are outside of the given interval. And then you just set up a table. It'll begin with the left endpoint. It'll end with the right endpoint of your interval. And then the critical numbers go between. You plug them directly into f. You only care about the highest or lowest y value. And then the highest output is the absolute max. The lowest output is the absolute min. So we have done this previously. All right, that's why it's important, guys, to conquer your problems, because if you've been conquering enough of these problems, this will come right back to you when you need it. Alrighty, so, and conquering them over and over, coming back to them as an anchor. All right, so page 10, find all local, so we're contrasting here the procedure for local extrema versus absolute extrema. So find all local extrema for the function below. Okay, so do we need the critical numbers of f or f prime? All right, that's always how it starts. Any of these graphics things are with critical numbers. And for the time being, they will always be critical numbers of f. So, all right, so the very first move is always critical numbers of f for now. So extrema will always start like this in your head if you're not writing this. So f prime needs to be 0 undefined. So the very first move is taking the derivative. The very first necessary on paper move. Okay, and then you have to factor this as much as you can. Okay, so that's going to be one factor. All right, when I do my sign test. Oh yeah, because we're going to need a sign test. So the critical numbers are -3 and 0. And I don't know until I do a sign test which of these correspond to maxes or mins. But all they're asking for are extrema in general. So what does that mean to have extrema on F? What would that mean about this F prime? That it has a sign change. Okay, so that's what we're trying to observe. Now, guys, if you are ever looking for a sign or a sign change, which you're always doing with graph facts, you're always looking for a sign or a sign change on something, then you need a number line, a sign or a sign change number line. And whatever you're looking for the change or sign on is going to be what you need a number line of. So you do a number line of F prime. So sign change, need number line, if that's what you're looking for. And you have to label the number line, put your critical numbers on it, and do some testing points. So I'll do -4. Okay, and so I have 3 separate intervals here that I'm doing testing points for. So I'll just do my sign tests over here. I'm going to have 3 of them, and I have 3 factors to plug into. All right, so -4 goes in. Positive, negative, negative. Positive, negative, negative. -1 goes in. Positive, positive, positive. And then 1 goes in, negative, positive, positive. Okay, so I'm getting a positive outcome, and a negative outcome on those intervals. So I'm only having a sign change at 0. Oh, and by the way, I probably should have put like zeros. I see some people do that. They'll put zeros above or U's, depending on if they got these values from F prime being 0 or undefined. I forget to do that a lot. It's not, you wouldn't get points off if you didn't do it. But, okay, so 0. Now, I'm saying, so I need to actually find this local extrema. So they're not asking at which values we have them. They want us to find them. So I have to take this and plug it back into F. And it would be nice to know if I had a max or a min. So let's look what type of sign change in particular, from positive to negative. So positive to negative on F, if you're going from an M-tan that looks like this to an M-tan that looks, or a tangent line. If you're going from a tangent line that looks like this to a tangent line that looks like that, and if everything is continuous, you would be looking at a max, okay? So max, all right, so 0, and then to actually get the max, F of 0. So you're plugging into the original. So local max, F of 0, and then I plug it in, and it's equal to -1. You plug it back into the original. F of 0 equals -1. Okay. Yeah, sometimes they just want the X value, but if you need the actual max or min itself, plug it back in to get the Y. Alrighty, guys, determine the minimum value of the function below on this interval. Guys, we learned the candidates test before graph facts because you don't need it. You don't need graph facts for an absolute max or min. So, absolute max or min. How do you know you don't need graph facts if they say min or max? You'll know if they say absolute, or if they say like on a closed interval. If they are implying the highest or lowest value overall on a closed interval, that is candidate's test. Candidate's test, and it always, candidate's test is on an interval. And the very first move is to find the critical numbers of f. So this is f, so I'm taking the derivative. And I'll factor it. Okay, so the critical numbers are 0, -2, and 2. All right, so guys, which of these fall outside of this interval? Because you don't need them. We're about to put these in a table with these as the endpoints. So 2, so we're not using that one. That one is irrelevant for this. So x and f of x. So we learned this before graph x because we do not need them. -2, oh, but starts at -3, I'm sorry. So -3, that's an endpoint. -2, 0, and then 1 is the other endpoint. Okay. Let's see. -3. Alrighty, and guys, you just, to get the y values, you plug these in. So you're plugging into the original. 0 is easy. I plug 0 in here and I get 5. I plug 1 in. Let's do it without a calculator. Little simple math, guys. You really should be trying to do it without a calculator. So f of 1, I'm getting -1 plus 8 plus 5. I'm getting 7 plus 5. That is 12. Alrighty, and then -2. All right, this is -2 to the 4th. Okay, so be careful here. You're raising -2 to the 4th, and you're getting +16, but you're negating it. So that is -16 plus 8 times 4 plus 5. 32, -16 plus 5 is -11. Nope, it would be 16 plus 5, sorry. Is 21. Okay, and then f of -3. Okay, so this is going to be -9 times 9. The -3 to the 4th would end up being 9 times 9. So this is -81. 9 times 8 is 72. And then plus 5. This is -9. Plus 5 is -4. Alrighty, they were asking for determine the minimum value on that interval. So it is f of -3 equals -4. So the absolute min is f of -3, which is -4. So that happened at an endpoint. It didn't even happen at a critical number. Okay, so shoot, I really want to do this last example. All right, but I'll just make another video. Or maybe I'll put it on the next one. Okay, guys, talk to you later. Bye-bye.